So any of you who have done debugging before might be asking, why would we use it? Since there's already a debugger that's just built into Python, why would you need anything else? And my answer to that is that I don't like using pdb. It's not very user friendly. You don't get to see the code. You can't see the code unless you run a command to display the current context. It'll show a certain number of lines before and after your current position. It doesn't have a lot of the features that other more modern debuggers have. And even though I consider myself experienced developer, experienced Python programmer, it's just a far more frustrating experience to use that as opposed to pudb. So and then pudb also gives you a number of other features that you just can't get in pdb. Like you can set watch expressions, so you could put in arbitrary Python code or names of variables, and they'll be evaluated every step you go through the code, so you can watch them change. You can go backwards to the previous function calls, and you can't literally go back in reverse execution, but you can jump back to the previous function call. You can see all of the variable states and all your watch expressions or whatever you have set at the time that function call was made. Further up the stack, which can help with troubleshooting. And one of the nice features that has come in handy on a number of occasions, especially with the multi-threaded applications, is remote debugging, where it will spawn a debugger that you can telnet into. So this won't be a very long demo. There's not a whole lot to display, so I'm just going to get right into it. To launch pudb, all you have to do is add these two commands. I like to put them on a single line. I think that might be how the upstream documentation for pudb recommends it. Notice it's pu.db, not which is kind of weird, but it doesn't match what you imported. So actually, I'm going to go ahead and switch over to here. First, just by contrast, I'm going to show what pdb is for those who haven't seen it. It's similar. You import pdb.setTrace, and when you do that, you end up here. You're in the debugger, and you can see this is the next line that'll be executed. If we look here, that's where we put our trace. And from here, if you want to see what the commands are, you hit question mark. You can see all these commands. I think most of these also work with the shortened versions of them. But L will list your current context. Any of these commands, you can just hit enter, and it repeats them. So this is just a look forward. Is looking forward like 10 lines at a time or so. And then if I want to step forward, I hit N, and you can see now I'm at this next line below, and I could keep hitting enter, and it'll keep on going one line at a time. It'll work if it's all you have. You might as well familiarize yourself with it. But I tend to avoid it just because it's it's not as fully featured as pudb. So by contrast, I'm going to do the same exact breakpoint here. I'm going to at the same exact point in the code. I'm going to launch into pudb, run the same function, and you get a much nicer debugger. It's the full screen with multiple panes. You have over on the right, you have your current variables, your locals. You have your previous function calls, your stack here right below that. And if you want to see your it's the same thing. Well, you can hit question mark. You can see all of your different commands, what they do. If I hit N, I can keep going. And if I wanted to If I wanted to step into a function, if you wanted to go into this function call here, you could just hit S, and now you're in that function. Well, this is like a decorator, but yeah. So now we're in the function. Now we're in a completely different file, and we're stepping through that code. If you want to hit, if you want to continue the execution anytime, you hit the C for continue, and now it resumed execution, right? So some of the other things you can do, you can, if you want to see, let's see. So we have a loop here, right? Let's say we want to just get what the value of the line variable, which is each line in the output. I went over to this variables pane here in the top right, and I'm going to type in line. That's literally just any Python expression. So I could also say like, oops, let me cancel. So now, as I go through the output, now you can see line is updated. I can also set a breakpoint here. So with B at my current position, set another one here if you want. Oops, cancel. Set another one here if I want. You can set as many breakpoints as you want. Now, if I just hit C to continue, next time it hits a breakpoint, it'll stop again. You notice the line has changed here, right? Like I could do, just to show you the effect that you could do any arbitrary expression, I could just do like line dot starts with, I don't know why you would do, why this would help, but it's just more of a demonstration, right? But like you can see that, oh yeah, this line does start with Python 3, cool, right? And then if I go back here, and you can see the next line. Now this line doesn't start with Python 3, so you can, so you have a much greater visibility into what you are debugging with pudb as opposed to the built-in pdb debugger. Go back to my notes and see if there's anything here. Anything else? I guess I didn't really put anything else. I did put there are some useful information about the key bindings. It's not an exhaustive list. Obviously, if you want to hit the question mark, you'll see all of them. And then if you want to do something, so the let me back up a second. If what we've been doing so far with the debuggers has been focused mainly on stuff that runs in the foreground. So this is good for like scripts or anything else that runs in a terminal. But if you got anything that's a little bit more complex, that has multiple processes or threads that aren't connected directly to a TTY, or that you don't have connected to a terminal, right? Then using either PDB or PUDB like this is not going to work because you won't have a terminal to interface with the debugger. And so this is where the remote debugging capabilities come in handy. To do remote debugging, you do need to tell the debugger what the screen geometry is, or what the number of columns and lines are. So yeah, you can. There's a couple different ways I put to get it. I think they both work on both Mac and Linux. I'm not sure about Windows. I try to avoid Windows. I can't speak to that. I'm pretty sure probably neither of these will work there. So you would need some other way of getting the number of lines and columns. And then the call and the import is just a little bit differently. You're gonna import from pudb.remote, and then here's your columns and your lines. Notice that if you run stty size here, it's going to give them to you in the opposite order. You still need, it's still like your width followed by your height of the screen, right? And then by default, I believe it's only going to listen. This may have changed. This may be redundant now. I'm not sure. But I thought that the default was to listen on localhost. It's helpful, especially since I do a lot of development within Docker containers, so I can develop against different platforms. I like to run the debugger on all interfaces because then I can just connect to the Docker container. which is what I'll be doing shortly in my demo of remote debugging. And then you can specify whatever port you want. And so if not, it'll I think it starts from, I don't know, I forget what from where 10,000 or something. I don't remember, to be honest. But I just put this in here as an example. If this port is in use, it just counts up, right? So it's going to take the next available port. That's if the port that it wants is in use. And then once the code reaches that point where you've set the trace, you will just telnet directly into the whatever the IP address is and whatever the port number is that it's running on. So going back to my demo screen here. So right here I have, this is in a background, like a multi-processing or process that is not it's like a maintenance process that's not that doesn't run on the console within Salt. It's the GitFS file server update code, and I've already filled some of this stuff in. You can see that here I have 147 width and 37 height, and I'm gonna just pre-grabbing the IP address of the container there, if my trackpad will cooperate. All right, so I'm gonna go ahead and just start up start up the daemon. Actually, this is technically running in the foreground. It doesn't matter. Still gonna hit the same code point. So even if you're not, even if wherever wherever that code break happens is not in the foreground, it's pudb is still going to try to notify you that that the break the trace point has been reached. So it's telling you to telnet into any interface, I guess, on port 9999. So I'm gonna go ahead and do that right now. And let's say I have the same exact interface. The only difference is that this is all happening over telnet rather than directly in the console. So I'm going to go ahead and show you that if you go ahead and if you were to change this, if I were to say I only want this to be 137 by 30, right? Then that's all you're going to get. It's not going to resize if you and redraw if you change your terminal size as well. You're limited by. Oh, that didn't work like the way I thought it would. Oh, no. Yeah, I don't think it likes the fact that I didn't give it the correct size. I honestly hadn't tried that before, and that's so I've broken the cardinal rule of live demos is doing something different that you wouldn't have done before. But the point is that you do want to make sure that you're telling it the correct screen geometry, or else weird things will happen. So that's really all that I have when it comes to the demo. Just a few more things though to mention about remote debugging. I already did cover that the next port will be chosen if the port requested port is unavailable. The other thing is that the telnet instance or telnet server that the pudb creates for you to connect into is not really that robust. You can actually trigger it by running an mmap scan, which I was trying to write some tooling to check and see if the breakpoint had been reached, because I had a lot of debugging, logging that was obscuring the actual line that tells you that the trace point has been reached. And I noticed that it was killing off, or it was never connecting, and I was noticing that the debugger wasn't even running, and I realized that nmap actually triggers the session to start and then immediately closes it. So don't do that. Another thing is that I found that For some people like to use if they don't have Telnet installed, but they do have Netcat installed. There's a Netcat, I think Netcat-T or something like that, that allows Netcat to act as a Telnet client, and that actually doesn't work. Same thing happens; it'll immediately disconnect. So you really do need to use Telnet in order to connect to it. So that's all that I really have, aside from some helpful key mappings here that might help as a cheat sheet. That said, if anybody's got any questions, I think we can move on to Q&A. I'm sorry, I'm not hearing you.
Helps to unmute, of course.
Yeah.
So thank you for the talk. That was excellent. I think we have one question in the chat. I think that was kind of answered, but it was asking, can you customize your color schemes? And I was wondering.
Good question. I haven't tried to do that before. I could really quick I still have one of the debuggers open. I could look at the help here. Preferences, Control P is your preferences. So, yeah, there are several themes built in, and then there's custom theme support. You do need to. It will take a little bit of you have to create your themes as a .py file. So the answer is yes. There's a number of built-in themes, like some of them correspond to some of the theme themes like Monokai, Solarized, and a couple other ones that are in there. But that would be in the preferences under Control P.
Cool. So question Python 3.6 introduces the new breakpoint keyword. Do you know if PDB would be able to take advantage of that?
I haven't tried it yet because I haven't written a lot of the stuff that I developed for at work. Because I work for CDN, the massive deployment that is very slow moving in what it upgrades. So to be honest, we're still using Python 2, and the Python 3 stuff that we use will probably be what's available on. I think Python 3.6 is available on CentOS 7. So I think eventually we'll come around to using it, but I haven't had the need to actually look into that yet. So I'm afraid I don't know.
Cool.
I would assume that I would assume that probably I would say the next major release may have it if the current one doesn't, because it's been a while since this. I think it's been since like early 2019 since there was a major release of pudb. So 3.6 is already out then, but it was considerably newer then. So I don't know.
Cool. And I have one more question. Since I don't see any else in the chat, if anyone else has any other questions, speak now. But one question I have is, would you be able to use the remote debugging for debugging like a celery task or something like that?
So I haven't used that before. I haven't used celery before. Can you elaborate?
Celery is like a queued job, runs Python in a queue, and so you have to have access to the source code of whatever's running. So, unless you have that, you're not going to be able to launch the debugger. Okay. You have to be able to you have to modify whatever code is running. So like anything created with PyInstaller where it's a single binary, you won't be able to use it with. And you might if you're it's a much more useful tool for something where you're developing where you're it's installed and you're running it out in like a virtual env or something like that. And I will also occasionally use it. I will if I'm really desperate, I will go into like the actual installed Python module and userlib, Python 3 dot whatever, and edit edit some module that I'm having trouble with, and edit it live and use it. But it's not I don't. I guess I'm not 100% sure, but if you had access to the source code of the test, then yes, for sure.
Great.